What is a prototyping? An interaction design. It can be any of the following and more: a series of screen sketches, a storyboard, i.e., a cartoon like a series of scenes, a PowerPoint slideshow, a video simulating the use of the system, a piece of software with limited functionality written in the target language or in other language. Goals of prototyping. Prototyping and evaluations happens throughout exploring requirements, market analysis, participatory design, choosing among alternatives, risky or critical features, go-no-go decisions, and practical usability testing. As early as possible, try out idea with a target user. Evolutionary development may deliberately choosing among multiple software platform, building software in incremental internet fashions. Journey of the prototyping process. We have 4 journey of prototyping process. First, goals. Second, functionality. Third, develop. And fourth, evaluate. Prototyping process. We have 4 prototyping process. First, establish prototype objectives. So, prototyping plan. And third is define prototype functionality. So, outline definition. Develop prototype. Executable prototype. And fourth, evaluate prototype. Evaluation report. Fidelity. Degree to which prototype accurately represents the appearance and interaction of the product. Judged by how appears to the person viewing it, not similarity to actual application, not degree to which the code and other attributes visible to the user are accurate. Fidelity spectrum. We have 2 fidelity. First, high fidelity. Close to final product, electronically faithful, use similar media. And second, low fidelity. Based from the final product, proof of concept, use if low cost, non-electronic media.
Low fidelity prototyping does not look very much like the final product. Uses materials that are very different from the intended final version, such as paper and cardboard, rather than electronic screen and metal. Used during early stage of development, chip and AC, to modify so distort the exploration of alternative design and ideas. It is never intended to be integrated into the final system. They are for exploration only. Example of low fidelity prototyping: storyboards, sketching, index cards, Wizard of Oz. Storyboarding: a series of keyframes as sketches, originally from film, used to get the idea of a scene. Snapshots of the interface at particular points in the interaction. Users can be evaluate quickly in the direction of the interface is heading. Initial screen, change the color, scan the ruler, place the order, alternate path, touch previous item, scan the shirt, delete that item. Sketches: drawing of the outward appearance of the intended system. Credibility means people concentrate on high-level concept, but hard to envision a dialogue provision. Using index cards. Index cards 3 times 5 inches. Each card represents one screen, often used in website development. Index card example screen 1. Index card example screen 2. Wizard of Box prototyping. The users think they are interacting with a computer, but a developer is responding to output rather than the system. It is the wizard, a person from the design team, who is responding rather than the system. Usually done early in design to understand user expectations.
High-fidelity prototyping. High-fidelity prototyping is a computer-based interactive representation of a product in its closest resemblance to the final design in terms of details and functionality. Choice of materials and methods, similar or identical to the ones in the final product, looks like more the final system, appearance, and functionality. Common development environments, Micropedia Director, PowerPoint, Visual Basic Web development tools. Whilst user expectation, users may think they have full a system.
Example, HCI prototype, iPad calendar, and Android used to build high-fidelity prototype for HCI adjustment. And this is the lo-fi and hi-fi. And another example of lo-fi and hi-fi. Advantages and disadvantages. The advantages of low-fidelity prototype is low developmental cost. Second, evaluate multiple design concepts. The disadvantages of it is limited error checking. Second, navigational and flow limitation. The advantages of high-fidelity prototype is first, fully interactive. Second, look and feel of final product. Third, clearly defines navigational skill. The disadvantages of it is more expenses to develop, time consuming to build. Third, developers are reluctant to change something they have crafted for hours. Compromises in prototyping. All prototypes involve compromises. Compromise in low-fidelity prototype. Device doesn't actually work. Compromises in high-fidelity prototypes. Slow response, sketchy icons, limited functionality available. Two common types of compromises. First, horizontal. Provide a wide range of function but with little detail. Second, vertical. Provide a lot of detail for only a few functions. Construction. Taking the prototypes or learning from them and creating a whole. Quality must be attended to. Usability, reliability, robustness, maintainability, integrity, portability, efficiency, and etc. Product must be engineered, evolutionary prototyping, and throwaway prototyping. State transitional diagram. A state transitional diagram, known in the UML as a state chart, is a useful model of user-computer interaction. It models the action of finite state machine with no state memory. This processor may be in only one state at a time. A transition to different state is caused by a occurrence of an event or by a condition becoming true. Components of a state transition diagram are state, where are the processor wait for an occurrence to cause a transition. Transition, an instantaneous change to another state. transitions are labeled to show the events which trigger them and the action occurring during that transition. An event may be constrained by a guard, a condition which must be through for transition to occur. A state transitions diagram may be decomposed into sub-diagrams in order to reduce its complexity. Modeling the interface dialog with state transition diagram. Two-state transition diagram can be used to model the user-computer dialogue. First, diagram for the human processor and one for the computer. The pair of diagrams shows the synchronization more clearly than a single diagram. Action of the user are the event which trigger transition in computer and vice versa. Real use case narratives. Expanded real use case narratives may help in designing the interaction. They record decisions about details of technology, which were deliberately omitted from essential narratives developed during analysis. And this is the example of state transition diagram. And that's all. Thank you.